Hi, welcome to another session of Circuits and Networks. My name is Ravikant Malajoshla, and today we are going to deal with single phase AC circuits, class 9, as a single phase supply, that is AC input voltage applied to series RLC circuit. This will be a normal derivation when you are going to apply AC signal to a series combination of RLC parameter. So this is how the circuit looks like. Let us go in depth with the topic. So the topic is single phase supply applied to series RLC circuit. So once this circuit is connected, the current will flow in the series network. Now once the current flows in this closed network, you can develop a voltage, that is resistive voltage, inductive voltage and capacitive voltage, so that the value of source voltage is equal to VR plus VC. What is our input? Input is the instantaneous value of the voltage. Instantaneous value of the voltage is given by Vm sin omega t. Vm is the magnitude of the voltage. Now from our previous analysis, we have come to a conclusion that when there is a pure resistor, the resistive voltage and current are said to be in phase. When this is a pure inductor, the voltage leads the current by 90 degrees. When it's a pure capacitor, the voltage lags the current by 90 degrees. So this conclusion we made according to our previous analysis. You can check these concepts with our previous videos with single phase RL and RC circuits. Now once we are done with the analysis and we know according to the KVL, that is algebraic sum of the voltage in a closed circuit is equal to 0, that is supply voltage is equal to the series combination of the voltage developed in the passive elements. So the phasor diagram can be derived from this analysis by taking current as reference and taking the resistive voltage which is in phase with the current and the leading voltage and the lagging voltage in this direction, and taking the Pythagoras theorem, obtaining the value of total voltage, that is this orange arrow, as Vs, which is a combination of the RLC circuit where inductor is dominating the entire circuit, thereby changing the circuit to RL circuit applied to supply voltage, that is AC in nature. So this is the phasor representation. So phi will be the angle between the voltage and current. Similarly, if capacitor is dominating the RLC series circuit, and with the above analysis, if at all you frame the phasor representation, VC will be dominating VL. So VC minus VL, which give you the value of total voltage under phasor diagram in this fashion. So this is how you obtain the phasor representation when RLC circuit is taken with input as source voltage, that is AC in nature. When inductor is dominating, this is the phasor diagram. When capacitor is dominating, this is the phasor diagram. Now based on these two relations, you can obtain the impedance triangle, which is a combination of real component, reactive component, and the total impedance obtained for inductive reactance dominating the RLC circuit under AC supply. Similarly, you can obtain the impedance triangle for capacitive dominating circuit under RLC applied to AC input in this fashion. What is the voltage? That is the instantaneous voltage, which is Vm sin omega t. Naturally, what will be the current? Current will be Im sin omega t plus or minus phi. This plus or minus phi depends upon the inductive reactance dominating the capacitive reactance, which makes I is equal to Im sin omega t minus phi. Similarly, if the capacitance is dominating the inductive reactance, then I is equal to Im sin omega t plus phi. So this is how the phasor relations as well as the equations are framed for RLC series circuit under AC supply. With this, I can get the power triangle with P as the real power, Q as the reactive power, and S as the apparent power for inductive dominating circuit. Similarly, you can obtain the capacitive dominating circuit, the power triangle diagram. So these are obtained, the impedance triangle and the power triangle, from the voltage triangles. Now from our previous classes, we know that when inductive is dominating the RLC circuit, it becomes RL circuit. In RL circuit, voltage will dominate the current. Therefore, voltage leads current by 90 degrees. Similarly, in capacitive dominating network, that is RC circuit, current will lead voltage. And you can estimate the power factor, which is cos phi, which is a combination of this voltage triangle, impedance triangle, or power triangle. When it is voltage, your hypothesis becomes V, your adjacent becomes VR, opposite becomes Vx. When it is impedance triangle, the hypothesis becomes Z, R becomes the adjacent, X becomes the opposite. And when it is a power triangle, S becomes the hypothesis, P becomes the real parameter or the adjacent parameter, and Q becomes the opposite parameter. So it can obtain by as VR by V, which is from voltage triangle, R by Z from impedance triangle, and P by S from power triangle. So this is how you obtain the relations of RLC circuit under AC input. So this is a short class in order to obtain the basic idea of RLC circuit under series combination of AC applied to passive elements. So I hope you like this video. Share among your friends, subscribe to my channel, and please press the bell icon for the future notifications. Thank you.